Okay, in this video we're going to be doing CalcAB problem set 24, problems, playlist in the description below. Let's do it. First up, find ddx of cosine cubed of x to the fourth. All right, so you might be at the point with the chain rule where you're just like blowing through these things and you're just doing like 3 cosine blah blah blah, right? But maybe not. I don't know. I'm going to color code this thing first. So we're really doing ddx of, so we got like something cubed, cosine of something, and then x to the fourth. That's what we're doing. So I need to take the derivative of something cubed, cosine of something, and x to the fourth. That's basically the chain that I'll follow here. So our derivative is going to be 3 times the thing squared. Derivative of the thing is negative sine of the thing times the derivative of x to the fourth is 4x cubed. And that's it. You might choose to rewrite it like this. In fact, I think almost everybody would. But that's it. All right. Next problem, chain rule problems. Not bad. It's scary when you first learn it, but not bad as you get better at it. Given the graph of v of t above, the velocity of a particle moving along a horizontal line. When is the particle moving to the left? All right, so moving to the left, velocity is negative. Moving to the right, velocity is positive. So we're looking for where the velocity is negative here. Look at the graph. On the intervals that I've highlighted, we are below the x-axis, and so, or the t-axis in this case, so, or the horizontal. So that's going to be where velocity is negative, so I'm going to write that up. So particle is moving left on 0 to 1 and 10 to 13 because v of t is less than 0 there. So I've given a reason, I've stated it, good answer. When is the speed decreasing and why? All right, so speed is decreasing when velocity and acceleration have opposite signs. An issue here is that I don't have acceleration, I just have velocity, and I can make inferences about v prime because I can tell if velocity is increasing or decreasing. So I'm going to, okay, so I'm going to go for it. Let's see. So I will say that these are the places where velocity is negative, but increasing, right? So which means that v prime, where a is positive. So v is negative, a is positive. These are the places where v is positive, but v prime is negative, which means acceleration is negative. So those highlighted places are the places where velocity and acceleration have opposite signs. So I'm going to try to write that up. I don't really love the way that I wrote this, by the way. So I wrote speed is decreasing on 0 to 1 and 12 to 13 because v of t is less than 0, while v prime of t equals a of t is greater than 0 there. Not wrong. But I think if I were going to write it again, I would write that v prime is increasing. And I would just like leave it at that. V prime is increasing. Or maybe v prime is increasing, therefore a is positive. A of t is greater than 0. I don't know. This is fine. I think you would get all the points. But I think there are better ways to write it. And then I did the other part. So I broke it into 2 things because there's like kind of 2 things going on. Then I said speed is decreasing on 3 to 5 and 8 to 10 because on those intervals, v of t is greater than 0, while simultaneously v prime is less than 0. And we know that v prime is less than 0 because v itself is decreasing. So I don't know. You get the points for what I wrote, but I think there are better ways to write it. That's what you always want to be improving, right? It's a theme. All right. Given x times y squared equals 8 and dx dt equals 3 at 2, negative 2, we want to find dy dt. So we're not finding dy dx. We're finding dy dt, and we were given dx dt, which means that every function is a function of t, which means this is kind of related rates if you've hit it already. If not, I mean, it's not really that different than like usually we're finding the derivative with respect to x, so the derivative of y is dy dx. Here we're finding derivatives with respect to t, so the derivative of x is no longer 1, it is now dx dt. The derivative of y is dy dt. And, you know, product rule, chain rule, all the rules still apply. So we're finding the derivative with respect to t of both sides. You got to really keep track of that. All right, so on the first one, we're going to go first, derivative of the second, 2y dy dt, plus second, which is y squared, derivative of the first is dx dt. So that's like a big difference, but like not a big difference. Not a big difference in terms of like how you do it, but in terms of what you're thinking, maybe it's a big difference. Now we got to plug in all the things we know, because we're solving for dy dt. So we know dx dt is 3. We know that x is 2. We know that y is negative 2. Make all of those substitutions. I'm not going to make you watch me plug those in. So I get 2 times negative 2, so negative 8 dy dt, plus negative 2 squared is 4 times 3 is 12. So we end up with negative 8 dy dt plus 12 equals 0. So I'm going to move the 12 over. I have negative 12 divided by negative 8, which I believe is 3/2. That's my answer. That's the end of this problem set. I hope you found this helpful, and good luck.